Hello, welcome to my talk on From Outage to Understanding. Today I'm going to take you through a story, from an outage on a web application, through the immediate response and remediation, all the way through the incident analysis. The story isn't any particular incident. Instead, it's inspired by various incidents that I've handled and investigated. I'm Andrew Parker. I've been a software engineer and manager for a while now. And what follows is the amalgamation of my study and experience in fostering a learning and just culture. And it's about applying that to when things go wrong. The team that we're going to hear about is part of a small company that has a web application that gets consistent but small usage. You'd say it's tiny compared to something like Google or Facebook, but I think that makes it all the more interesting. It's more like what many of us handle every day. The team has around 15 software engineers and 3 system administrators. Now, the application itself is a fairly normal web application. It's hosted on-premise, and there are a number of different application servers from different parts of the system and a few databases for different data domains. There's some back-end batch and stream processing servers, but I'm going to say, I'm giving you that as context where you get a sense of what the team has. It's not that important. You'll see as we go through the story. Now, as I take you through the story, I want to point out the procedures that I use, the aspects that are important and those that are not so important, and I'd like you to reflect on your own experiences while we go on this journey together. What would you or your team do in these situations? How is your context different? And what impact does that difference have on the choices available to you? Can you see yourself using some of these techniques in your organization? Now, before we get into the details of the incident, I want to go over some preliminaries about how we're going to go thinking about things. I consider this part important because part of having a learning culture is having that mindset that gives the best chance of learning. Next, we'll pick up with the team when they learn that something is wrong and see how they behave to address the issue. The bulk of our time will be in the aftermath. We'll go through the many different ways the team looked at what happened, and at each stage I'll give you a chance to think about and share incidents you've been involved in and how this might apply or not apply to your situation. Blame. So, a fundamental tenet that we need to work from is that learning from an incident is a group activity. Our technical systems and our social systems are larger than any one of us. And so in order to change the complete socio-technical system, we need to take into account as much of that whole as we can, and we need to spread the understanding as widely as possible. Blame prevents us from being able to learn because it results in hidden information and destructive dynamics. Holding people accountable and blaming people are two different things. Blaming people may, in fact, make them less accountable. They will tell fewer accounts. They may feel less compelled to have their voice heard, to participate in improvement efforts. Blame-free or no-fault systems are not accountability-free systems. On the contrary, such systems want to open up the ability for people to hold their account, so that everybody can respond and take responsibility for doing something about the problem. That's what Sidney Dekker says about creating a just culture. At the same time, and he would agree, we also need to acknowledge that the world is complicated. Legal, regulatory, power struggles, and so on all may hinder our ability to safely ask for, understand, and disseminate accounts. The investigation, the questions asked, the publication of findings all need to take into account the ability of the whole surrounding organization to maintain the safe environment for learning, and ignoring that fact will create more harm than good, as honest accounts get used to apportion blame and undermine safety and learning. So this leaves us with the question, how can we behave to increase learning and decrease blame? In reality, this is a whole practice in and of itself, and is something that each and every one of us can continue to learn to work on for our entire lives. Much like anything you want to do, it takes practice to build this skill. But there isn't any need to despair. You can help yourself immensely by reminding yourself of these 5 assumptions. As you are in an outage, think, I have some information, so do other people. Be curious about what others see when you recall that each of us may see things that others don't. And when you're certain that you're right, temper yourself by reciting, I may be contributing to the problem. That's a powerful one. I may be contributing to the problem. When you find yourself in a disagreement and feel yourself digging in, unlock your mind by meditating that differences are opportunities for learning. And before you decide that they must be doing this to get a leg up, think, people may disagree with me and have pure motives. These 5 assumptions are what Roger Schwartz put together for the 8 behaviors for smarter teams. The assumptions and the underlying values, transparency, curiosity, informed choice, and accountability and compassion, are not something that we all default to. However, if you can work these assumptions and values into your life, then you're much more likely to show curiosity and kindness, which will lead to better outcomes. The U.S. Forest Service, which in the United States, as its name says, takes care of the national forests. They do forest management, they deal with wildfires a lot, they do all sorts of things there. They have an approach to learning from accidents that they call facilitated learning analysis. The linked description that you see on the slide of it, I find it to be fascinating reading, to see how a discipline that is so different from our own puts these same ideas to use. At the core of facilitated learning analysis is an acknowledgement that what the leadership thinks is happening and what is actually happening is where the most interesting organizational learning lives. And that is the key for us as well. What we have in our heads, the way we think everything works, probably doesn't completely match with the reality. So they say, treat accidents and other unintended outcomes as precious opportunities to look deeply into the operation to better understand how employees perceive and manage risk. And then also, employees make mistakes, but most of the time, almost continuously, they are creating safety. And so, this is the accountability that we're looking for. What were the judgments people were making? Effective storytelling is the most powerful teaching tool we have to convey wisdom and experience gained from living through an incident. The dictionary defines wisdom as the ability to think and act utilizing knowledge, experience, understanding, common sense, and insight. To effectively impart wisdom, we must share mishaps as well as mastery. What we are going to be doing is we are aiming to impart wisdom by investigating the technical details, the personal details, and compassionately telling the story of what happened. Sometimes the story will be uncomfortable, either from the standpoint of the people who took the actions or the standpoint of the people who thought they knew what actions were that should have been taken. Handling that discomfort in a way that conveys the experience and wisdom is what leads to learning. We need stories and narratives to make sense of our world. Let as many people as possible include themselves in that story, either because they were there or because they can imagine themselves there. So, how does all of that sound? It sounds a bit daunting to me. So I think we can get through this. I think this is a lot to ask ourselves and others, which is why compassion is so important, but we can get through this. Now let's get to our story. At 13:32 on Wednesday, the 23rd of January, PagerDuty alert appeared on the phones of all 5 people on the in-hours escalation. 2 minutes later, the alert cleared. 3 of the 5, who had already started looking at the status pages of the application, had determined that the site was responding intermittently, which explained why it had cleared the alert without them doing anything. The 3 investigated for a short time and saw no obvious cause, but could see that the problem continued. They called a war room at 13:37. A war room. So what is a war room? It's a place for coordinating the response. It's a place for having that quick communication. It's a place where people know what role that they're playing and how they can help out. So you have a few key roles: the leader, the communicator, the scribe, and the executors. So this war room is where we're going to be coordinating. Beside those roles, there's another key part, which is real-time voice communication. I've seen a lot of people try to coordinate responses through asynchronous messaging, and that gets you part of the way, but it really doesn't get you that higher bandwidth communication, real-time communication that you really need. So I suggest you really need voice communication. You also need shared facts. Now for this, what I've found is that there's a document. Google Docs works excellently for this. Multiple people can edit all at the same time. Those edits show up very quickly to everyone else. And you can, in that place, coordinate your shared knowledge of the situation. It also provides a place for the scribe. The scribe keeps a timeline of things that are known, decisions that are made, information that's found. It also provides a place for everyone to be throwing in information as they find it. So you've got the written record, the roles, and the communication. Now, there's actually one little piece of the communication part that I want to call out as well. Make sure you use a communication tool that doesn't impact your ability to respond to the incident. For a while, my team had been using Mumble because it's a very low impact, very high throughput, low latency application for voice communication for gamers. But the rest of the time, we used Hangouts, Google Meet, for communication. But the problem was Google Meet on many people's computers made it so slow that they kind of couldn't do other work at the same time. Which meant that if we tried to use that during a response, well, people wouldn't be able to respond. And that's just not useful. So you have to think about those kinds of what works for the organization and the people in order to be able to do your response. The call for the war room went out, and within a few minutes, most of the development team had joined the war room Mumble channel and opened up the Google Doc. Justin took the role of war room leader. I and another, Alex, shared the scribe role, and I picked up communication. Everyone else who joined was an executor. Justin immediately asked who knew what was going on. Adam gave a quick recap of what he knew, which was that the application is randomly responding with 500s. Pingdom detected the site down. They haven't been able to figure out what the cause is, and all of the systems report an OK status. A few people started investigating the logs, and others took a look at the graphite metrics. As they discover things, they report back to the group on the voice chat what they found. Throughout this, the scribe is keeping time-stamped notes of what is being recorded and decided. Eventually, one of the app servers is determined to be the origin of the 500s, but there isn't any explanation as to why. At 1346, the group decides to try a restart of that app server. The restart is completed at 1348, but the problem persists. Justin lists the options of removing the app server from the load balancer and investigating offline, or continue looking. The team has a short debate about whether removing it from the load balancer would preserve the crime scene enough to investigate later, as it isn't clear what is causing the problem. They aren't sure, and so decide to continue the investigation a while longer in the current state. At this point, Gary joined and listened for a short time as the team worked. Then he asked, "Is it a problem with the app server 3? I just provisioned that because I saw the pool size was set at 3, but we only had 2 running. I assumed that everything was set up for it on the dependencies, but hadn't checked." The team knew that the only real dependency that could have been having a problem is the database. Someone pulled up the logs, another person pulled up connection pool metrics, and another looked at the firewall configuration on the database. They all pointed to the same thing. The app server was attempting to connect to the database, and Netstat showed all the connections to be in the SYN send state. The IP tables rules on the database did not list the third app server in its rules. A run of Puppet on the database applied the correct firewall rules, and all of the errors disappeared. The war room is there to recover, so that's the main focus. However, as we could see from the debate that the team had, there's also an aspect of learning. If you can trade a little more downtime for a lot more understanding, especially if it is understanding that you can't get any other way, it might be reasonable to take more downtime. The key of the war room is to make that an informed, explicit choice rather than an accident of hidden knowledge. As the response progressed, information got shared both verbally and written. Logs, screenshots, links, anything really pasted into the war room document. The scribe transcribes or notes what people are saying. The scribe might need to ask people to put what they are seeing into the doc so there's a complete record. Now, the core cycle of the war room is hypothesis generation and testing. Get those ideas clearly stated and out into view. Search for the data or perform experiments to support or disprove the hypotheses. When you're doing this, be careful about untested assumptions. Those assumptions where you think, well, of course it works this way, so I shouldn't even bother with that. Those are the ones, try to find some evidence that it really is that. With practice, the team can be testing out several hypotheses at once. The key here is asking people for an account of what they have found since they last checked in. Bringing the information together so that everyone, as much as possible, is working from a shared set of facts. Now, at that point, you can already hear this. The core is account, not blame. We want people to share their account. And on that account, the next part is the communicator. The communicator will be the source of accountability to others at this time. What is happening? Who is impacted? How long might it take to resolve? The communicator can act as a synchronization point as well of the understanding of the team by checking with them that the update that the communicator is about to send out is correct. The way this would work is that the communicator says, all right, I'm going to let the team know, I'm going to let the rest of the organization know this is what's happening. Here's my draft email. Can someone take a quick look and make sure I've got this understanding right? That provides that shared fact of what is happening. And then the communicator sends that out. And now that understood shared fact has been shared even more widely, and the accountability is there of how are we responding. The resolution. The war room completes when a remediation for the problem has been found. There may still be work to do to implement it, but what needs to be done is no longer in doubt, and it is clear who needs to do what. You're out of this hypothesis testing phase. There may be follow-up actions to clear up other issues that need an urgent response, so coordinate that. Now, another thing you need to do is make sure that those follow-up actions are clear to everyone, especially the people who need to do them. Agree on the communication that needs to go out, explaining the resolution, and that acts as that final synchronization point of the war room. And something learned from hard mistakes, if you have outstanding alerts, you might want to take a step back at the end of your war room and go through everything that is still critical. And when I say critical, you say like it's red. It's telling you something is going wrong. The reason you want to do this is I've learned from experience that while you're there and handling one incident, another problem could have shown up and passed by your attention. So take a look through your dashboards, through your system status, and make sure you know why and the severity of everything that's still not working right. Does it fit the hypothesis that you have of how you need to resolve this? Do you understand the impact each one of those is having? That kind of, let's make sure we understand the situation before we say we understand the situation. And then one of the last things you need to do, or maybe it's more of a continuous thing you need to be doing, is secure the crime scene. Now, the crime scene is this whole environment, this whole thing of what's been going on. Part of the reason we have the scribe and we have this shared document is because that allows us to record what we knew at the point in time so that we can understand it later. At this point, you need to think a bit more as well about, you're going to need to dig deeper into what happened. And to do that, you'll need lots of information: log files, system configurations, working documents, anything else. You might want to make copies of terminal output so that you know the exact error messages that someone saw. You might want the command that they used and the time they did it. You'll need to think about how long your retentions are. So if you don't get to this until Monday, to look into this a bit more deeply to understand exactly what happened, are your logs going to rotate and get lost? Do you need to have something back a few weeks that is about to disappear in order to understand the system state, like a before and after? If so, secure that. Make sure you have it so that you can come back to it later. If you have a virtual machine that needs to stay in its current state, well, make sure that you're not going to have a deploy send stuff out to it, or an automated system come and shut it down because it's no longer needed. Make sure that you're not going to lose the information to understand. Now it's time for your next judgment call. How bad was this? How much effort do you want you and the team to put into learning deeply from this? Were there any near misses that people found disturbing? Just because something terrible didn't happen doesn't mean that we shouldn't dig into it. Those near misses can be the biggest indicator of a difference between how others think things are working and how they are actually working. So give it some thought. Ask around. Find out, is this something that people want to understand better? In this story, there are a lot of unanswered questions and a lot of things we can learn from. And we're here to see how all the aspects of the analysis work, so let's just keep going. Now, a little bit more background. As we go through the analysis, there are 3 rules that we need to live by. Each has an implication for how we continue. The first one is to avoid counterfactual reasoning. Now, as we talk about what happened, we want to talk about what happened rather than what didn't happen. So we want to base everything on these shared facts. Now, it can be informative to think about what should have happened, to think if the team had done this or if the team had done that. But we should be using that difference as a jumping off point to get to why people took the actions they did, which had to have been what they considered to be the right thing at that time. We also want to avoid normative language. This is where you say they should have or they properly. And these words keep us from deeply understanding the situation. They verge on blame and judgment and move us away from curiosity. And we want to avoid mechanistic thinking. Mechanistic thinking is the idea that if each individual component of the social and technical system just works as designed, then there would have been no problem. We need to aim for understanding the whole system, understanding how they interact, how all of these parts work together. And that will lead us to much better understanding of the system. So the first thing we need to do is come to an agreement about what we're investigating and how we're going to look at it. What's the problem? Meaning, what was the undesirable outcome? And from that, we then go and collect our shared facts. A timeline and technical analysis. The timeline has as its basis the log from the war room, expanded as far back and forward and in as much details as needed to inform the understanding of the system and understanding of the problem. The technical analysis is to get to an understanding of what happened in the technical system. Quite often there are a lot of unanswered questions. Why did the database not respond? Why did it come to our attention in this way and not this other way that all of us seem to have expected? What explains the puzzling graph that led us astray during the response? The technical analysis needs to answer those questions. Sometimes this is the most intensive part of the investigation. Sometimes it's over in a matter of minutes. A technical analysis could take quite some time as you perform experiments to confirm ideas about what happened and dig through logs to understand what actually happened step by step. For example, my teams have recreated the failing system in the past in order to be able to perform packet captures needed to explain why two servers hadn't been able to communicate. Also, look back at the crime scene. This is why we tried to secure it. The problem statement that the team came to as they worked through this was that some of the virtual machines that make up the application were not able to communicate with each other for a prolonged period. And this resulted in approximately 33% of user requests failing, which rendered the application unusable for 47 minutes. Now, this is, we could say, the initial problem statement. From this point, the team iterates on it. We think, is this really the right way? You can think of other ways that we could have framed this problem. This one says, our problem is more of this technical nature. This application was unable to communicate. You could say that there's another problem statement that we could have put in here instead, and it's almost more along the lines of this impact, which is the amount of time it took us to notice and respond to it, 47 minutes. We could say that our problem was that we were in an unusable state for 47 minutes. Each one of those different ways of framing it will produce a different analysis and a different investigation. So working on what is it that we consider the issue here frames what we do next. And in this case, the team, through a bit of discussion and a bit of back and forth, came to, no, we consider this a fairly standard technical issue that came up. That doesn't mean that everything that went wrong was technical, but there's something, this is the way that we're thinking about it. So let's run with that for a while. Now, from that problem statement, we come up with the timeline and technical analysis. The timeline, in this case, goes back 4 months to a time when an app server was created and then turned off. And then to right now, when that app server was once again turned back on. The technical analysis, we get into the question of why were these things not able to communicate with each other? And we can see here a bit of that impact of the problem statement, of the framing, on what we investigate as the technical analysis. Our problem statement was about the virtual machines of the application not being able to communicate with each other. And so we needed to explain a bit of why were they unable to communicate with each other, and why did it appear in the way it did? In this case, why did it look like the application had a large number of connections and the database had none, or a very small number of connections? And here we can see that we investigated, and we found, the team found that it was in the way that our firewalls work. The drop rule means that the packet is just dropped on the floor. The other end of that connection doesn't get an indication that it will not work. And what I cut out on this to keep space on the slide, and the application also did not have a timeout for a connection. And so it just kept building them up. The technical analysis would probably also get into why was it exhibiting in the 500. It would also get into why the run of the puppet command that remediated it actually did. And these might just be a single sentence. It's just like putting it down, making it clear so that we can all work from that we're not fighting each other, we're not misunderstanding what we did and why it worked. Now, someone may disagree, they may say this isn't what happened, and then we can go and investigate that. Excellent. That is productive conflict, and that is giving an account that makes sense for everyone involved. So the next thing that we need to do, now that we've got all of those shared facts of when things happened, what happened in the technical system, now we need to start thinking a bit more about what should have been happening, what was happening in the human system. And for that, you need to think about what written procedures do you have that you can apply to the incident. You're going to write down what actually happened. This is where your timeline will come in very useful. And what the procedure says should have happened. And when there's a difference, that's the chance for learning. That's the chance for saying, oh, what happened here? The deviations that we find aren't there to be judged. It's not there to just say, that's the cause. That's exactly why this happened. But we need to explain, why did this make sense to the person at the time? That's what we're looking for. What I've found in many cases is we don't have an exact written procedure of what should have happened. Usually in computer systems, either it's automated and so it's a single command and it just runs, or it's some sort of one-off where we're all just using our judgment and trying to figure it out. And in those cases, where it's more of our judgment and what we're trying to do, we write down what did happen, and then you go and you start talking to a few people, and you find out kind of what is the consensus about the way something should have been done. Be careful in doing this, because what we're not looking for is the hindsight bias. We're looking for, given what you think, what is the reasonable course of action to do in this situation? And now we once again do that difference analysis, that gap analysis. And we ask, okay, that's not what this person did, or that's not what these people did. So why? What were we missing? And what we're trying to do is give us a story, give us some reasoning to narrow this gap. And once again, I'm going to say this is where the learning comes from. Now, the gap analysis that the team came up with, in short, was that what normally should happen is that you change the configuration in the CMDB and you push those. You run Puppet on the dependencies of that system, and then you provision the new server. What actually happened was that a configuration difference was noticed and it was provisioned. Now that's an interesting one, because what normally would have happened in a provisioning application server is that someone would have been putting that in. But in this case, it was already there. So, well, why was it already there? What can we do with that? Let's have a discussion about that and what that means. And then we have another one, which was that Puppet should be run on the dependencies. Well, Puppet wasn't run on the dependencies because the reasoning was, based on what the person could tell, it had been there for a long time. And so Puppet probably had been run already on all of its dependencies, and so it would have been configured correctly. Turns out that assumption was wrong, but all of us, as we thought through it, had a similar thinking. Well, it wouldn't have stayed incorrect for a long time. And so it gives us a way of thinking, why would it have stayed incorrect for so long? Or maybe it wasn't, and we just didn't understand something else. Let's go and check that. And now we can go and interrogate and understand everything a little bit more closely. At this point, I'd like to pause and give a minute for everyone to think about an incident that you've had in the past. And think about the problem statement, the framing that you'd give it. The timeline and the technical analysis you probably don't have too clearly in your head, but maybe you do. Maybe the technical analysis is something that you have and you can clearly say exactly what went on. And then think about the gap analysis. Think about the procedures in the response, or the procedures that led up to the problem, or the procedures that happened through various other parts. What were those? And then what actually happened? Quite often, the gap analysis is where people will really be saying, "Oh, he should have done this," or she should not have done that other thing. And those are the interesting places. So I want to give you a minute or two to think through, in your own past, what have you found there? And share them if you can. Now that we've gone through that kind of basis of moving from the framing to the shared facts to the analysis of difference, we get to the next tricky bit, causes, or not causes, or chain of causation. And in this case, something that I think we should all keep in mind is that the world is not as simple as there is a cause and there is an effect. Quite often, the same event can happen multiple times, and it's only in this case, with a combination of all sorts of other things, that it leads to the outcome that we just saw. So rather than thinking of this as causes, think of this as just meaningful events. Things that we would point to, or groups of things that we would point to, and we'd say, that is interesting. That is relevant for this. And as we go through them, you can use a few different categories to help you think through it. Are there things in the human world that are interesting events? Are there things in the machine world that are interesting events? Are there processes? Are there environment? So an example of something in the human world might be someone was tired. They hadn't slept well. A thing in the machine world may be that the system had been up with a memory leak and reached a critical memory point. In the process world, where those gaps, where we saw this thing was not done, that thing was done, those kinds of things. And in the environment, I don't think it affects us all that much, the physical environment, but it could. But just kind of the stuff around us. For us, environmental causes can be user behavior changing. We had maybe you had an outage because some client was working on a script and it started hammering your services, creating problems for others. And then as you go through this, on each one, think about, is this a fact, opinion, or a guess? And what I've found is just that thinking where you're aiming to get to the level of facts. Guesses are something that you should probably go away and think, can we find more about this? Can we support this? Opinions are probably there as well. And what I've found is quite often inside those, there is some fact that we can use. And that investigation as a group, that thinking through it as a group, helps us to once again to figure it out. Now, there is something that I want to point out, and I around the idea of coming up with these causes, and it's something that Sidney Dekker said, which is that the very act of separating important or contributory events from unimportant ones is an act of construction, of the creation of a story, not the reconstruction of a story that was already there, ready to be uncovered. What we're doing here is we're making that story. We're making that narrative. We want it to be a shared one, and we want it to be based in some real world. But what we're not able to do is we're not able to somehow uncover a story that was just there. We are creating it as a group to somehow explain this and impart wisdom. So the team, in this case, brainstormed cause and effect, and we do it in these little diagrams. We do it in a drawing system where we can create boxes, put in ideas, people brainstorm them and are throwing them onto this really fast. And then as they come out, start trying to put them together and say, well, this kind of had to have happened and probably led to this. And through that, what we're looking for is, where are the nodes, where are the common elements of all of this? You might call it, we're looking for the root cause, but back to that idea, there's no single root cause. We're looking for the impactful causes, the impactful events, the ones that led to a lot more. And here we have things like the connection timeout is set to a default value, which meant that the database connections never time out. And due to the way that it reports errors on the application status, the application reported that it was always healthy. So that's an interesting one. There's multiple places in there that we could think about as where we think the most important parts are. And then we have another one that we talked about already, that the config had been in place for a while. And that led to the decision to only provision the server. And it also led to that the assumption was that the app would be working just fine after we're just adding another server. So those are all facts. And this was a discussion. The team would have gotten together, involved multiple people, maybe pulled in others as they realize that this discussion is verging into a territory that none of them are involved in, and they need the input of others. And so this is a brainstorm. And the next part is, from this big cloud of ideas, to start trying to make sense of it. And my guidance here is to grab no more than 3 of the items from that brainstorming. Probably want to aim for just 1 or 2. And these are the ones that all of you are agreeing are most important. I've done this in the past through voting. Sometimes the voting is unnecessary. Everyone just points at it and says, well, that's the one that we think is important. And on those ones that you consider important, just dig a bit deeper. Look around it a bit more. This is kind of like picking it up and examining it and thinking about it and trying to figure out what do you do with this? And the way that I've found is useful for this is where the 5 whys technique now appears in this. Throughout all of this, if you've ever been interested in like RCA's root cause analysis or anything like that, you've probably heard 5 whys. Well, if you ask why 5 times, you get to the root of the issue. What we found and what we were trained on at one point by someone who does these kinds of analyses at a pharmaceutical company is that the 5 whys are for understanding that cause rather than finding it. And that's what we found was eventually useful. And so you take those important events and you just ask why. Why is it like this? Why did it happen that way? Why did we think this was the right thing? And that last one, why did we think this is the right thing, goes to the assumption that any action taken was done because the person believed it was the right thing to do. Why did they do that? Because they thought it was the right thing. Why did they think it was the right thing? And that's the interesting part. And you can check your reasoning by reading it in one direction with the whys and reading it the other direction with therefore. This isn't foolproof, but it's just a level of making sure that we are telling a story that we believe. And that's the key. We're telling a story that we believe. We're trying to make sense of this world. And for that, I want to point out the idea of sense-making, which is that it refers, reading this definition, refers generally to those processes by which people seek plausibility to understand ambiguous, equivocal, or confusing issues or events. And that's what we're doing here. These events quite often are ambiguous. We will quite often equivocate about whether or not really is this the cause or not, or how should we split this thing up? How do we make sense of what this is? And that's what we're going to try. So the team worked through this and came up with 2 events. One was the application reported healthy, and the other one decided to provision only that one server. Or decided to only provision the server, as opposed to also run on dependencies. And we've decided that of those 2, the application reporting healthy was probably the biggest one. The reason is because we have a general sense within the team that failures happen. And so it's our time to detection and our time to recovery that really matters. So the real point where our system should have told us that something was wrong is when the application was still reporting healthy. The application shouldn't have reported healthy. It was not healthy. And so that's the thing we want to understand. That's the event that we think is the most impactful in this. So why did the application report healthy? Well, because nothing that it monitored had errored. Why was nothing that it monitors erroring? Well, because the connections in the connection pool stayed in a connecting state indefinitely. They never errored. And why did they do that? Well, because the pool config uses default connection timeouts, which is none. There is no timeout. And we could continue that line of reasoning a little bit further if we wanted to, or we can kind of hit a point where we consider, we understand this now. Now let's try this in the other direction. So the connection pool config uses default connection timeouts of none. Therefore, the connection stayed in a connecting state indefinitely. Therefore, nothing that was being monitored errored. Therefore, the application reported healthy. And that one kind of works. Makes sense. I think we're getting to a point as the team that we're kind of like, this makes sense. We understand this. Now, if we look at this other one, team, it wasn't the major one, so we were okay leaving a little. It's not quite as strong. So they decided to only provision the server. Why? Because we assumed that the config had applied everywhere already. Why? Well, the config had been in place for a long time. So why had it been in place for a long time? The third server was part of a prior incident response. Now, that one doesn't quite follow. And we can see that if we go backwards. The third server was part of a prior incident response, therefore the config had been in place for a long time. And that doesn't seem... There's something missing there. So the team at this point would be thinking, well, this isn't quite fitting together. Why? How do we fit this together? Maybe this chain of why is wrong, that we've gone down a path that just doesn't matter, doesn't make sense. Okay, can we do this in a different way? Some way that makes more sense to us about why this is the way it is. So now that we've gone through these important events, all of the brainstorming, the technical analysis, the timeline, the problem statement, now we want to figure out what should we do about this. Now, out of the technical analysis, and we've probably all encountered this, out of the technical analysis, you can get crystal clear, oh, let's just fix this. Okay. In this incident, the team got that very clearly from the technical analysis that the IP tables could probably be changed. Rather than a drop, which is generally considered the way you should configure a internet-facing firewall, there's no need for the internal firewalls to not send back like a rejection packet. That would have caused all sorts of things to just work out. Okay, cool. Well, let's put that in place. That can just happen. As we get into these more and more ambiguous things, it's not always clear what action we should take. And so we need to now brainstorm some changes. Taking everyone who is involved and thinking through what changes could we say, it's a brainstorm. There's ones that you might think that's not great. There's ones that you think that's cool. Go with it all. Don't try to shut people down on coming up with what could be done. Now, once you have all of those ideas out there, you now have to fend off good ideas. What you're looking for to fend them off is what we call line of sight. That from that change that's being proposed, through the cause, through that important event, to that problem, you can construct, as a team, you can say, this is the chain of reasoning that connects those together and why this fix impacts that cause which addresses our problem. And that's what you're looking for. Now, there's another filter that you can apply as well, which is, does that fix take you in the direction that you actually want to go? We all have, as technical departments or as companies, directions that we want to take things. And sometimes the fix to address that problem won't take you there. So you might say, the only thing that we can think of to fix this would move us away from what we're trying to do. Well, don't do it then. So we don't need to always find a change to make. Sometimes the change comes about simply from us better understanding. And the last filter would be cost. How much was that impact, and how much effort do we want to put into this? We've already done the effort of all of this analysis, all of this understanding. How much more do we want to put in to fix other things that we understand now? And we may say none, or we may say a lot, but that discussion has to happen. So the team, after they did their gap analysis and after they did their brainstorming and their why asking, they came up with a few changes that they could make. They could make Pingdom more sensitive to errors. They could educate the customer success people on how to alert the development team. They could configure connection timeouts in the DB connection pools. They could modify config management to run Puppet on dependencies when provisioning, and they could migrate to Kubernetes. As you probably noticed, none of this was on a modern cloud system. Well, we could migrate there. Then that would have alleviated a bunch of these issues. It would have automatically configured all of these things. But if we look at the line of sight, make Pingdom more sensitive to errors doesn't really address the primary issue, which is that the applications were all still reporting healthy. It does eventually get to that problem. So it kind of gets to the problem, but it doesn't go through what we think was the reason we had this problem. We could educate customer success on how to alert the dev team. Well, we didn't say that the problem was really about how we learned about it, or even how long it took. So this one is kind of like unresponsive to our problem or to what we considered our cause. Configure connection timeouts in the DB connection pools. Well, yeah, that would have caused the application to report it as unhealthy. Excellent. Let's do that. And modify config management to run Puppet on dependencies when provisioning. This is that second cause, which is we only ran the provision, we didn't run the dependency configs. Well, let's have it do that automatically. Also, line of sight. And migrate to Kubernetes. That would have addressed part of this, so sensible, but the cost of that is far more than any of us are willing to put in right now. So it gets crossed off. And here we have us coming to agreement and almost consensus about what we have learned from this event. Now that we've gone through all of that, I hope that you are interested and excited about understanding what goes on in your organization even more. I want to just leave you with a request, which is to assume that everyone is acting with their best intentions, using the best knowledge that they had available, and that you are there to seek to understand. What you will find is quite often much more muddy and unclear than a cut and dried cause. Involve people in that journey. Analyze everything as a group and tell the story so that everyone can get on board. Any changes that you want to make based on what you learn, try to make sure that they're clearly connected to what actually happened. And once you've done that, you will have a group that learns together and improves together and understands why they're doing it. thank you, and good luck.